Happy Thursday, everybody. Today is Thursday, October 22nd, and today we're going to be on Unit 3, Lesson number 9, continuing our work with place value, using it to add or subtract. Our specific lesson today is about estimation with addition. And our learning target, today I will estimate addends and sums to check for reasonableness of solutions. Remember, for our last lesson, we talked about what addends means. Those are just the numbers that you add up to get a specific sum. Like what two numbers or what numbers are you adding up to get a specific sum? That's what addends mean. Our essential questions are remaining the same. How do we make sense of larger numbers? And how does understanding the value of digits help answer real-life math problems? What is estimation? And so what I want to do is we're going to pause for a minute. I want you to think about, what does estimation mean to you? Are there certain words that you can think about what estimation means to you? And we're going to pause, and I want you to, on your slide, just go on and click right beside the number and write down what you think estimation means to you. If you have more than one definition or idea about what you think estimation is, then just put more than one on there. Okay, so you've had an opportunity to fill in your part right here about what do you think estimation means. Okay, so now we're going to go to our next slide. And our next slide, I've got several different types of estimation. Basically on this side over here, these are the types of estimation, basically what is estimation. And over here, these are examples of estimation. So we'll start with the first one, okay? So if you put down on that previous slide, rounding or adjusting, and that's exactly in line with what I have right here. So one type, rounding or adjusting. An example with rounding, you'll be able to round down or round up based on a digit's place value. Then adjust that estimate depending on how much the rounding affected the original value. So each time a number is rounded to a smaller place value, the estimate gets closer to the exact number. So rounding, you have to be flexible with that. An example of rounding would be right here, 568. 568, if you want to round it to the nearest 100, it will be 600. So 568 rounded to the nearest 100 would be 600. So that means that you're looking at the hundreds place right here. Okay? And what is it closer to? Would it be closer to 400 or would it be closer to 600? So one way to determine which way do you go with it is you look at the number right to it, the next place value beside it. Okay, so if I look beside it, that number is 6, so it's like over half. So I would want to take this one up to 600. Okay, that's just an estimate. Now, if this number that was right next to it was a 4 or 3, then this entire number would be closer to it would be closer to 500 actually. Okay, so round it to the nearest 10. If you were to round this one to the nearest 10, now you're going to have some flexibility into what you decide to round it to. Okay, if I don't specifically ask you to round it to the nearest 100 or the nearest 10, then you, when I say round it to the nearest number, then you would get to choose sometimes about what you want to do, round it to the nearest 100 or round it to the nearest 10. But if I did want you to round it to the nearest 10, it would be to 70. So you have to look in the tens place. The 6 is in the tens place right here. And is 6 going to be closer to 7? Or is it closer to 7? Or is it closer to the number below 5? Okay, so one way to kind of look at it is, well, what about the number right next to it, the place right next to it? Okay, it's 8. So it's higher up. So this 68 right here will be closer to 70. Okay, so the 68 right here will be closer to 70. All right, so another type of front-end estimation. Estimation will be called front-end estimation, okay? So for a front-end estimation, it's just really a really quick estimation method where you don't really consider the place values right next to it like we did on this one. For instance, you would just say, if you're adding up numbers such as, let's say, 568 plus 420 plus 162, you would just look at the hundreds place. And you would just take those individual numbers, the values of each number in the hundreds place, which right here, you've got the 5. This will be estimated as 500. And the 420, you would just estimate that as 400. The 162, you would just estimate it as 100. So that's like a really, really quick method of estimating on the front end. And when we say front end, we mean in the highest place value spot that you have, which in this case is the hundreds. Okay, and when you add those estimates up, it will give you an estimate of 1,000. So our next type of estimation is convenient or friendly numbers. So when you use convenient or friendly numbers type of estimation, what you're really doing is you're choosing a number that is convenient and it is close to the original number, and it's just easy for you to work with. Okay, you're choosing a number that is convenient, it's close to the original number, and it is easy for you to work with. Okay. For example, when you use convenient or friendly numbers, an example would be if you had the number 518 and you were being asked to round that number, you would pick a number that is more convenient for you and easy for you to work with. It could be 500, you could say 515, or you could say 525. Those numbers are close to the original number and they're convenient and easy for you to work with. Okay. So on our next slide here, it says estimate the sum 512 plus 285. So not necessarily solving the problem in your notebook. What I would like for you, just using one of the methods that we've talked about on our previous slides, and I'll go back for a second here. One of the methods that we've talked about on our previous slide, rounding and adjusting, front-end estimation, or using convenient or friendly numbers. I want you to estimate your answer for this in your notebooks. We're going to pause for a minute. Okay, so I'm just going to demonstrate on this one using the rounding method. All right, so I'm going to take the first number here, which is 512. I'm going to round this to the nearest hundred, and 512 is close to 500. Okay, and then when I look at the second number here, 285 is closer. It's going to be closer to 300 than it is to 200. So I'm going to say 300. These are my estimates. And when I add these up, all right, that's an estimate for that, okay, using the rounding method. And you could have used a different method, and that's fine. If I don't specifically tell you to round it to the nearest hundred or to the nearest 10, then you can use whatever method that you'd like. If you use the front end method, you would just add, you would say 500 plus 200. Okay, you would say 500 plus 200 if you use the front end method on that. All right, so, and there's a way that you can kind of check using a number line. You can check using a number line to see if your answers are really reasonable. All right, so I'm gonna click on this right here in just a sec. So in just a minute, you guys are gonna click on the zoomable number line right here, so you can kind of practice with your estimates. But first, let's go and write this problem down in your notebook so you'll have it. So write down the 512 plus 285. 512 plus 285. Remember, we're just doing estimates right now. Just want you to write in your notebook so you have those numbers available. You don't have to keep coming back to your computer. So I'm going to click right here, and I want you to just kind of watch me first. All right, so when you click there, it brings up a different screen. Zoomable number lines is what we have. So here's my number line, but I need to, the only numbers I have on here now, you got 0, 1, 2, 3, 4, 5, 6, 7, and I need numbers that are much bigger than that. So I'm going to use the zoom feature on this one, okay? So I'm already zooming out. That means that I'm just going to go and take my cursor right over here at the near the 0, and I'm clicking to bring it in. So I'm trying to get it where you see the numbers are getting bigger, 100, 200, and our numbers that we added up were 512 plus 285. So I want to be able to get at least through 500 on here so that we can kind of see. This is just to give you an idea about where does your number fall, what is it close to, okay? So our first number was 512. So let's take a look at this right here, and let's see where would 512 fit on this number line. Where would it be? All right, so on our number line, 512, of course, it would be, this is 500 right here, so it wouldn't be right there. This is 600. It wouldn't be right there. It's going to be somewhere in the middle, somewhere in between. And we know that this is a halfway point right here, okay? And halfway will be 550. So it is not, that's too far. So now 512 would be closer to 500. It would be really closer to 500, okay? It will be somewhere right along in here. But our point is, what number is it closer to if I wanted to round it to the nearest 100? Okay, it's closer to 500. So when I see 512, which would be maybe right in here, round it to the nearest 100, it will be 500. And now let's look at the 285. 285 was our second number. So let me go on the right. So 512. And the other number was 285. Those were the two numbers that we added up. And what we're doing now, we're just identifying, just on the number line, how can I round it to the nearest 100? So 285. Where would 285 be on our line? It would be in between the 200 right here and the 300. Okay, now mentally we can say to ourselves that this is the halfway point between 200 and 300. That would be 250 right there. 285, then now it would be somewhere in here. Okay, it would be somewhere in here. And with that being said, is it closer to 300 or is it closer to 200? So it would be closer to 300. So that's why I would round it. When I say round it to the nearest 100, it would be rounded to 300. All right. So the estimate, rounded number here would be 500, and the rounded number for 285 would be 300. Okay, so that's how you can use your number line to help you identify what number is it closer to. Okay, so our next slide is time for us to practice a little bit more. Okay, so let's practice. I want you to turn to page 151 in your math binder. So turn to page 151 in your math binder, and we're going to take a look and do some estimates to check for reasonableness. So the instructions say solve each problem using the standard algorithm. Use estimation to check if each answer is reasonable. So we're going to pause for just a few minutes. I want you to go ahead and in your notebook, I want you to work on these two problems and make sure to, this is not showing the entire screen, but do everything on that page, okay? Okay, so you've had an opportunity to work on practice with page number 151, and this one, let's see. Okay, and now we're going to take a look at our answer key. Okay, and let's take a look at our answer key for that page number 151. First problem is 672 plus 829, and you were required to do this in the standard algorithm. So you add it in the standard algorithm. So you always start with the ones place. As a reminder, you start with the numbers in the ones place. The 2 plus the 9 is 11. So you bring down the 1 in the ones place, and you have one group of 10 that you have to regroup. Okay, one group of 10 over here that you regroup, and now you have 1 plus a 7 plus 2, that equals 10. So you bring the 0 down here, and now you have one group of hundreds that you have to regroup. So you have 6 plus the 1 plus the 8, that equals 15. So you have the 5 you bring here, and this 1 has actually been regrouped to the thousands place. So there's nothing else to add with that, so you bring that down. So your actual answer is 1,501 for this one. Estimates. So using estimates for the 672, if you're estimating by to the nearest 100, 672 is closer to 700. All right, if you estimate it to the nearest 10, you're looking for, what is this, the number in the tens place closer to? Is it closer to 7 or 8? So you could have estimated to 680. Okay, now you would not be wrong if you estimated it at 670. That would not be wrong either. 829, our estimate for that one, the nearest 100. Would it be closer to 800, closer to 900? It's closer to 800. So you estimate it as 800. And for the tens place, the 2 is in the tens place, would 29 here, would that be closer to 30, or would it be closer to 20? It would be closer to 30, so 830. So our estimate would be approximately just around 1,500. Now, is that close to our actual answer of 1,501? Yes, it is. It's really close. So that tells us that our answer is reasonable. That tells us that our answer is reasonable. All right. So let's go over to the right. The two numbers over here being added up, 7,390, 9,036. So the ones place, you got 0 plus the 6, 6. You have in the tens place a 9 plus the 3 is 12. And I know this is a little bit off center right here. For some reason, it was copied that way, okay? So you have 12, and you have to regroup. You bring the 2 here, you regroup the 1 into the hundreds place. So 3 plus the 1 plus 0 is 4 right here, okay? And now you have 4, so now you just need to add up the thousands place. 9 plus 7 is 16, so you have the 6 that you bring down to the thousands. And this 1 was actually regrouped over to the 10,000s place. 6, so you have 16,426, okay? And here are the estimates for that one to the nearest 1,000, and also here to the nearest 100, and also here, this one's estimated to the nearest 1,000. And here is your estimated sum. And here you have your answers for the next two, guys. And there were some regrouping that you did have to do for these. So take a close look at them. And here at the bottom, these are your estimates. These should be your estimates here. Okay. And at the very bottom, it says, explain why you would use estimating when adding. So basically, why would you estimate when you add? And a possible answer for you, a really good answer for you would be, after I add two addends, I can use estimation to check and see if my sum is reasonable. If I round each addend to the largest place value, I can mentally add the rounded sums to see if my actual sum is reasonable. So you estimate really to make sure that your actual answer is reasonable. If they're really close, then your answer is reasonable. So for our next slide, this is your independent work here, okay? So it says Nancy is estimating answers to these problems. You have one for A is 184 plus 409, B 231 plus 276, and C 891 plus 195. Which problem has a sum greater than 1,000? Explain. So that means that you are going to have to add each one up, or you're going to have to do an estimate for them. Okay, so which problem has a sum greater than 1,000? Explain. So I want you to type your answers. You're going to do it on the slide. Type your answer right here. Indicate whether it's A, B, or C, and then explain why you say that your answer is what it is. And the other one over here says, which problem has a sum of about 600? Remember, the sum is the answer to an addition problem. So you determine based off of estimating which one of these has a sum that is about 600. You type your answer in here, A, B, or C, and you explain by typing it in here, okay? And at the bottom, which problem has the smallest sum? Explain how you know. So using estimation, you're going to determine which one of these is going to be, has the smallest sum, and you would put your answer here. Now, you can work, I want you to work the problems in your notebook. So work them in, when you write your estimates down and you're actually adding your estimates up, solve that inside of your actual notebook, and you can put your answers in here, okay? And our next slide is our last one for the day. It says complete independent practice on that previous slide, and also I want you to practice on Dreambox. And make sure to have at least 5 of those done by Friday.